Hello, my name is Vicki Kurtz. I'm with Imaging Systems Technology. Today we'll talk about our plasma shell technology as well as talk about its application for water purification. Let's first start with an explanation of what a plasma shell is. A plasma shell is a hollow, gas-encapsulated structure. When a voltage is applied across the shell, the gas inside of the shell ionizes and emits light. The light it emits is across the spectrum from microwave through ultraviolet. Our shells have many uses in electronic applications as well as in water purification. IST has control over its shell manufacturing process. We can manufacture our shells in a great size range, from 500 microns to 12 millimeters. Additionally, we have control over our shapes. Our shapes can be spherical, cubed, hexagonal, or triangular. How does a plasma shell emit light? When energized, the gas encapsulated within the shell will produce UV that will strike the phosphors within the shell. The phosphors will then produce light that exits the shell. By properly selecting the gas and the phosphors, the shells can produce UV, visible light, or infrared light. No mercury is used to produce UV light. One application for plasma shells is for water purification. Our shells can be manufactured to produce either UVA or UVC light. Shells that emit UVC light can be used for sterilization. Shells that emit UVA light may be coated with titanium dioxide and then be used for advanced photocatalytic oxidation reactions. The problems encountered with the traditional method of Ti02 is that the UV light source must be in direct contact with the Ti02 for the advanced oxidation reaction to occur. Additionally, contact time between the water and the energized Ti02 should be maximized. As shown here, the Ti02 particles have little contact with the light source and the contaminated water. Therefore, the reaction is not efficient. IST is developing a scalable advanced oxidation system using Ti02 with our plasma shells. We are coating our shells with Ti02, which provides direct contact with the Ti02 and the light source. Our spheres create a homogeneous light source throughout the water. Clusters of our shells provide agitation to the water, which reduces laminar flow and increases the contact time between the sterilization source and the contaminated water. The shell clusters will act as a mechanical filter to prevent larger objects from being passed through the system. Shown here are our plasma shells emitting visible light in water. Notice the shells can be submerged in water. Notice the light saturation in the water. And notice that light is being emitted on both sides of the shell, providing as much light as possible into the water. Thank you for listening to my presentation on IST plasma shells. If you have any further questions or need information, please contact me at vkurtz@teamist.com.